This video is focusing on learning target number 2. I can write and name formulas for binary ionic compounds. Again, binary is just 2 elements. The foundation of understanding how to name binary ionic compounds, though, is going to apply to four total learning targets. So this video is super important to get a general foundation of how to do this. As a reminder, what is an ionic compound? An ionic compound is when 2 elements come together, and rather than sharing electrons, they transfer electrons. So one atom gives up an electron, one gains an electron, and by doing that, they become absolutely charged, and the force of attraction of opposite charges keeps them together as a compound. Remember, they don't form molecules, they end up forming crystal lattice structures. And when we look at the formula, we're just looking at basically a formula unit, the most basic ratio of elements that you can get within the formula, within the crystal lattice structure. So, binary ionic compounds, how do you name them? Well, every binary ionic compound will contain 2 elements, a metal and a nonmetal. The metal is going to be your cation, the nonmetal will be your anion. And honestly, naming them is super simple because you're just going to name them what they are. So your cation you will name based on the metal, sodium, aluminum. Your anion you will name what the nonmetal is, replacing the ending with "ide", so chloride or sulfide. The reason why the naming is so simple versus for the molecular compounds where we had to have prefixes is the fact that when a metal comes together with a nonmetal, it can only come together in one way. It can only come together so that they form their common ionic charge. Sodium will only bond with something if it can form a +1 ion, and chlorine will only bond if it can form a -1 ion. Overall, you can see your molecule is neutral. There's no charge written on it. So when your 2 ions come together, they always have to come together to make a 0 net charge. What do the subscripts tell us? The subscripts tell us the ratio at which these 2 elements are coming together. So there's 1 sodium and 1 chlorine in the sodium chloride molecule. They're coming together at a 1-to-1 ratio. In the second example, there's 2 aluminums with 3 sulfurs. They're coming out with a 2-to-3 ratio. Okay. Why are there different amounts of each? Again, it's based on charge neutralization. Aluminum has a +3 charge, sulfur has a -2 charge, meaning if they came together just a 1-to-1 ratio, okay, if they were just like, hey, I'm going to go ALS, that doesn't work because aluminum is going to form an ion of a +3, and sulfur is going to form an ion of a -2, giving you an overall net charge of +1. This would have an overall net charge of +1, meaning it's not a stable compound. It will be reactive still, and that's a problem when you're trying to make a compound. So they're always going to come together in some way to neutralize, and you can have as many as you need come together to neutralize. Okay, that's what this picture shows too. Calcium is always going to make a +2 ion, chlorine is always going to make a -1. So if calcium and chlorine come together, they could never come together at a 1-to-1 ratio because you'd still have an overall net charge of +1. You need 2 chlorines for every 1 calcium to actually become neutral. So how do we name binary ionic compounds? Well, as I said on the last slide, you literally name them what they are. So for the metal ones, you would name them just their names. So Na+ would be sodium, Ca+2 would be calcium. For the nonmetal, you are going to change the endings to ides. So chlorine would be chloride, oxygen would be oxide. Putting those together, the molecules that are formed, as seen here, are to make everything neutral. Okay? And then you just name them based on the 2 pieces. Okay, so this is very, very straightforward. If you had sodium with chlorine, it would be sodium chloride. Well, that's me. This is a lowercase letter. Okay. If it was going to be sodium with oxygen, that would be sodium oxide. If you're going to have calcium with chlorine, that's going to be calcium chloride. And then if you're going to have calcium with oxygen, that's going to be calcium oxide. Okay. Every time, simply naming the two pieces with what their names are. That's it. No prefixes, no nothing. Naming binary ionic compounds is super simple. Formula writing for binary ionic compounds is where it gets tricky, in my opinion. Okay. When two elements come together in the binary ionic compound, remember they're coming together to make a neutral compound. So, for example, if you had the compound magnesium nitride, they are coming together, magnesium and nitrogen, to have an overall charge of 0. For you to figure out what the formula is, you have to figure out how many of each you need to make the compound have an overall net charge of 0. I don't give you a prefix. I don't say dimagnesium. I just tell you magnesium nitride because you should know, based on common ionic charges, what happens. Bummer. So, you need to do some work. Let's do it. If magnesium and nitride were going to come together, here's how I name these always. I write down my symbols for each of the two elements present. So magnesium is Mg, nitride is nitrogen, which is N. And then I write down my charges. Now, I write down my charges just so I can use them to work, but these things aren't charged overall, right? Magnesium ends up having a charge of +2, and nitrogen has a charge of -3. So, I figure out how these two things are going to come together in order to become neutral. Right? How many magnesium and how many nitrogen do I need? Well, there's one awesome method that sometimes works that I can show you, and it's called the crisscross method. Okay? The crisscross method goes like this. Whatever charge there is on your first element, that's what's going to become the subscript on your second. And whatever charge you have on your second, that's what's going to become your subscript on your first. You do not get any charges once you're done with your formula, so you've got to erase it. But this will work. Okay, this is one way it will work. You can also look at it more about how to balance charges. So again, if this was a +2 charge and this was a -3, it's about finding the lowest common multiple of these two. Since 6 is the lowest common multiple of both, you need 3 2s to make an overall charge in a +6, and you need 2 3s to make an overall charge of -6. So there's a lowest common multiple idea you can use. Crisscross will work for the most part, but understanding where it comes from is how you're not going to make mistakes. The time crisscross does not work is when the fact that your formula unit always has to be your most reduced ratio. So if you have a 2 and a 2 and you do the crisscross and you give me 2s, that's wrong. Okay, they should just be a 1-to-1 ratio. So your last step, if you do the crisscross, is always to reduce your subscripts if you can. Okay. So when trying to figure out the neutral formula, you're trying to figure out how many you need to neutralize. I won't really do the crisscross method again, but I wanted you to at least see it once because it's a really simple, non-intelligent way to do this. So let's try some of these. Let's do sodium bromide first. So sodium's Na, bromine is bromine, just Br. Sodium has a charge of +1, bromine has a charge of -1. They come together in a 1-to-1 ratio and they are already neutral. So you just erase your charges and that is your answer for sodium bromide. You might want to make them a little close together, but that's about it. Let's do calcium oxide. Calcium oxide. Okay. Figure out your charges based on the location of the periodic table. Calcium is a 2+, oxygen is a 2-. They are already neutral, which is awesome. Here's where your crisscross method could fail you, because if you were like, charge here, put it here, charge here, put it here, a formula unit always has to contain the most reduced ratio. This is not the most reduced ratio. 2 to 2 is the same as 1 to 1, but 1 to 1 is the most reduced ratio, and that's the right answer for the formula unit for calcium oxide. So be aware if you use crisscross, you have to be intelligent still. Magnesium chloride. Magnesium's Mg. Chloride is Cl. Magnesium has a +2 charge. Chlorine has a -1 charge. How many of each do I need to neutralize? Well, then I need 2 1s to cancel out this +2 charge. And so the final formula is magnesium as MgCl2. Aluminum oxide is AlO. Aluminum has a +3. Oxygen has a -2. This is honestly the trickiest one you'll find. And if you do enough 3-2s, you'll see like, oh, it works the same way every time. If aluminum has a +3 charge and oxygen has a -2 charge, you will always need 3 oxygens and 2 aluminum. Okay, that's one of the trickiest ones because people are like, oh no, I need a multiple of 6. Well, it always works the same. Okay, it always works the same. So to write formulas for binary ionic compounds, you need to figure out how many of each element you need in order to overall create a neutral ionic compound. And that's learning target number 2.